Hi, welcome to this Corbettmaths video. In this video we're going to look at simultaneous equations, and we're going to look at how to solve simultaneous equations whenever there's three unknowns and whenever they're in context. So questions whenever there's a context to it. So here we've got a coffee shop sells three different sizes of coffee. So they sell a small coffee that costs X pounds, a medium coffee that costs Y pounds, and a large coffee that costs Z pounds. And on Monday, the shop sold 100 small coffees, 300 medium coffees and 200 large coffees for a total of £2,100. And part 1 of this question says to show that x, y and z satisfy the equation x plus 3y plus 2z equals 21. So quite often with these simultaneous equation questions, whenever they're in a context, you might be asked to create each one of the equations before you then solve the simultaneous equations. So that's what we've been asked to do here in part 1. We've been asked to create this equation. And to create this equation, what we're going to do is we're actually going to focus on the bit of information we're told in the question. We're told that the shop sold 100 small coffees, 300 medium coffees, 200 large coffees for a total of £2,100. So let's use this information to create an equation. So 100 small coffees. Well, each small coffee costs X pound. So to find the total cost of those 100 small coffees, we would do 100x. We would do 100 times the price of the coffee. If each coffee was £2, we would do 100 times 2, which is £200, and so on. Now, we're also told that 300 medium coffees were sold. So to find the total cost of those 300 medium coffees, we're going to do 300 times y. So we're going to do plus 300y. So that'll be the total cost of the small and medium coffees. Now we also need to consider the large coffees. 200 large coffees were sold and they cost Z pound each. So we would do 200 times Z to find the cost of those large coffees. So it's going to be plus 200 Z. So that would tell us a total cost of 100 small, 300 medium and 200 large coffees. But we're told in the question that they cost a total of £2,100. So that means that this will equal £2,100. So that's fantastic. We've now created an equation. Now that equation that we've created isn't quite what we'll be asked to show, but we can actually get it to that, because if we look at it, we've got 100x, 300y, 200z and 2100. We can divide this whole equation by 100. And if we divide everything by 100, we'll get this. Because if we take 100x and divide it by 100, we'd get x. If we then had 300y and we divide it by 100, we'd have 3y. If we had 200z and we divide it by 100, we get 2z. And if we had 2100 and we divide that by 100, and that's equal to 21. And that's it. That's what we're asked to show. So we've done part 1. So part 2, we'll probably be asked to create another equation. So let's have a look at that. So we're then told on Tuesday. So part 1 was on Monday. Now we're on Tuesday. The shop sold 50 small coffees, 45 medium coffees and 200 large coffees for a total of £2,500. And we've been asked to show that x, y and z satisfy the equation x plus 9y plus 4z equals 50. Okay, so we just want to create another equation here. So 50 small coffees, well, they each cost X pound each, just to make sure that, yep. So we're going to do 50 times X, we're going to do 450 times Y, and 200 times Z. And then we'll add that all up, and that'll be equal to 2,500. So let's do that. So 50X plus 450Y plus 200Z will equal 2,500. So that's fantastic. We've created an equation. Okay, so now we just need to simplify this to be this. And let's see what we can divide everything by. So we've got 50, 450, 200 and 2,500. Well, they're all divisible by 50. We can divide this whole equation by 50. So that means we can divide each of them by 50. 50x divided by 50 would be x plus 450y divided by 50 would be 9y plus 200z divided by 50 would be 4z. This is fantastic. And finally, 2,500 divided by 50 is equal to 50. And that's it. So that's it. We've created that second equation. Okay, so part 1, we created the first equation. Part 2, we've created the second equation. Now let's have a look at part 3. So we've now got Wednesday. That makes sense. Monday, Tuesday, Wednesday. We're then told the shop sells 300 small coffees, 300 medium coffees and 100 large coffees for a total of £2,200. And we've been asked now to show that x, y and z satisfy the equation 3x plus 3y plus z equals 22. Okay, so let's make our equation. Each small coffee, let's just recap. Each small coffee costs X pound. Each medium coffee costs Y pound. And each large coffee costs Z pound. So we're going to do 300 times X, so 300X plus 300Y plus 100Z is equal to 2,200. And actually you can see here straight away, we're going to divide everything in that equation by 100. So we get 3x plus 3y plus z equals 22. And that's that third equation. So that's fantastic. So we've done part 1, part 2 and part 3. So forming the equations given the context. Okay, now let's have a look at solving them. So part 4, the question says solve, and then we've got those 3 equations to find the cost of each size of coffee. So we're going to solve these simultaneous equations that have got 3 unknowns to find x, y and z. And x is the cost of a small coffee, y is the cost of a medium coffee, and z is the cost of a large coffee. So let's do that. Okay, so to solve these simultaneous equations, I'm going to number them. I'm going to number them 1, 2 and 3, just so I can keep track of what we're doing in this question. Okay, so looking at equations 1 and 2, I can see that we can eliminate x straight away. We can just subtract the equations. And I'm going to do 2 take away 1. So I'm going to do equation 2 take away equation 1. So equation 2 is x plus 9y plus 4z equals 50. And equation 1 was x plus 3y plus 2z equals 21. And then if we subtract those equations, and I like to write, just going to make sure that line's a bit tidier, 21. I'm just going to make sure it doesn't go through what we've got there. And I'm going to write here for, and then here I'm going to write sub for subtract. So x take away x, well that's 0. 9y take away 3y, that's 6y. Plus 4z take away 2z, that's 2z. And then we've got 50 take away 21, that's equal to 29. So that's fantastic. We've got an equation without the letter x in it, without that variable x. We've eliminated it. And I'm going to call this equation 4 because it's very important, this equation. It's an equation without the letter x in it. Okay, so we've got one equation without the letter x in it. Now let's find another one. Now we've used equations 1 and 2. Let's use equation 3. Now let's get a 3x. So I'm thinking I can multiply either equation 1 or equation 2 by 3 and then do a subtraction to get rid of the x's. So I'm going to times equation 1 by 3 to begin with. So 3 times equation 1. And if you times everything in equation 1 by 3, we're going to get that's equal to 3x, because 3 times x is 3x, plus 9y, plus, and 3 times 2z would be 6z, equals, and times 21 by 3 would be 63. So that's fantastic. We've got an equation here with 3x in it, and equation 3 has got 3x in it. Now I'm thinking we should do this equation take away equation 3. So I'm going to do that 3 times equation 1. Some people call that equation 5. I'm just going to say 3 times equation 1, subtract equation 3. So here's 3 times equation 1. I'm going to write equation 3 beneath it. So 3x plus 3y plus z equals 22. And now I'm going to subtract to eliminate those x's. So subtract. So 3x take away 3x, well, that's 0. 9y take away 3y is 6y. Plus 6z take away 1z is 5z. And then finally we've got 63 take away 22, and that's equal to 41. So that's, I'm just checking that, 22 plus 41 is 63. Fantastic. Okay, and I'm going to call that equation 5. So we've now got 2 equations without the letter x in it, without that variable x. So now let's focus on these 2 equations. This is fantastic. We've got 6y and 6y. So we can actually take these 2 equations away from each other. And I'm going to do equation 5 take away equation 4, because that will leave us with 3z. So we're going to do equation 5. So we're going to do equation 5 take away equation 4. So equation 5 is 6y plus 5z equals 41, and then we've got 6y plus 2z equals 29, and we're going to take them away from each other, and then that'll eliminate the y's. 6y take away 6y is 0, 5z take away 2z is 3z, and then we've got 41 take away 29, and that's equal to 12. And that's great. And if we divide both sides by 3, we get that z is equal to 4. So that's great. We found that z, the cost of a large coffee, is equal to £4. Okay, that's fantastic. Now let's substitute that into one of our other equations. I'm thinking equation 4 or equation 5, because they're the ones, if we substitute that into either of those 2 equations, we can find out what y is. I'm going to choose equation 4 here. So I'm going to sub that into equation 4. So I'm going to substitute z equals 4 into equation 4. So equation 4, if we just write it down again, was 6y plus, scroll up, 2z plus 2z equals 29. Okay, so that's equation 4. We want to substitute z equals 4 into that. So we'll have 6y plus, and 2 times z, 2 times 4 is equal to 8, and that's equal to 29. And then if we want to solve this, we take 8 away from both sides. So we take away 8 and take away 8. So we get 6y equals 21. And then we'll divide by 6. And if we divide both sides by 6, we're going to get that y is equal to 3.5, or £3.50. So we found the price of a large coffee, £4. We found the price of a medium coffee, £3.50. We're now going to substitute both of those into one of these equations. And I'm going to choose equation 1 here. So x plus 3y plus 2z equals 21. So let's write that down. So sub z equals 4 and y equals 3.5 into 1. So let's write equation 1 down again. So that was x plus 3y plus 2z equals 21. Okay, so there's equation 1. We now need to substitute this in. So x, well, that's what we're trying to find, plus 3y, so 3 times 3.5 is equal to 10.5, so 10.5, plus 2z, well, 2 times 4 is equal to 8, and that equals 21. So now if we work this out, we've got x plus, and 10.5 plus 8 would be 18.5, and that's equal to 21. And then if we just take away 18.5 from both sides of the equation, we get that x is equal to 2.5 or £2.50. So that's great. And I'm just going to write these down here. That the price of a small coffee is £2.50. A medium coffee is £3.50, and a large coffee is £4. And there'd often be an answer section for you to write that down. Usually the bottom right hand corner of the question, you could write that into the answer section. And that's it. I just want to mention also we can check our answer. If we substitute those values into equation 2, we can check in 2. And if you've got time to check, that's fantastic. So equation 2 is x plus 9y plus 4z equals 50. Well, let's check this. X, that is 2.5, plus 9 times y plus 31.5, because 9 times 3.5 is 31.5, plus, and then 4 times 4 is equal to 16. And the question is that equal to 50? So 2.5 plus 31.5 is equal to 34. Plus 16, and is that equal to 50? Well, 34 plus 16 is 50, so 50 equals 50, so that's right. Yeah, that's it. So we know we're correct, and if you've got time to check it, then that's really useful. And that's it. So in this question, we were given a situation about the prices of coffee, small coffees, medium coffees, and large coffees. We were told some information in terms of how many were sold and the total cost. We then had to create each of those equations and then solve them. Now, this one was quite nice because the situations were how many were sold on a Monday, how many were sold on a Tuesday, how many were sold on a Wednesday, and they were quite straightforward. Now, what we're going to do is we're going to look at another question. And that other question, some of the equations are probably a little bit trickier to set up. So let's have a look at one now. Okay, so our next question is about Emily, and Emily's training for a race, and as part of her training, she completes 3 types of run. She does short runs, medium runs, and long runs. And we've been asked to let x, y, and z represent the lengths in kilometers of the short, medium, and long runs. So a short run is x kilometers, a medium run will be y kilometers, and a long run will be z kilometers. And if we carry on, we're told in June, Emily completes 16 short runs, 12 medium runs, and 6 long runs, and the total distance that she ran in June was 240 kilometers. And we've been asked to show this equation that 3x plus 2y plus z equals 40. Okay, so we've told some information. Now this first equation is actually quite nice. It's quite similar to the ones we were given in the last question, because 18 short runs, their total length would be 18 times x, so that'll be 18x, plus the 12 medium runs, each one of those is y kilometers, so that'll be 12y, so 12y, and then plus the long runs, each of those is z kilometers, and the 6 of them, so plus 6z, and that equals the total distance is 240. So that's the equation. That's quite nice setting that one up. And if we have a look here, 18x, 12y, 6z, and 240, they're all divisible by 6. So if we divide the whole equation by 6, 18x divided by 6 is 3x, plus 12y divided by 6 is 2y, 6z divided by 6 is just z, or 1z, and that would be equal to 40. And that's it. So we've done part 1, and part 1 was quite nice there. It was quite similar to those equations in the last one. Okay, and then if we carry on, we're then told that Emily says that the length of 2 long runs is 8 kilometers longer than the total distance of 2 short and 2 medium runs. And we've been asked to show that x, y, and z satisfy the equation z minus x minus y is equal to 4. Okay, so this one's a little bit different because we're told that Emily says that the length of 2 long runs. So each long run is z kilometers, and there's 2 of them. Let's just go back and check that. Z is the long run, yep. So the 2 long runs, that'll be 2z. That distance is 8 kilometers longer than the total distance of 2 short and 2 medium runs. Well, 2 short runs would be 2x, and 2 medium runs would be 2y. So we've got 2x and 2y, that's 2 short and 2 medium. And the total distance of 2 short and 2 medium would be 2x plus 2y, because 2 times the short run plus 2 times the medium run, the distance, if you add them together, will be 2x plus 2y. Now we're told that the length, Emily says that the length of 2 longer runs is 8 kilometers longer than this total distance. In other words, if you take this distance away from this distance, you get 8. If you do the total length of 2 long runs, which is 2z, and you subtract the total distance of 2 short and 2 medium runs, so 2x plus 2y, that's going to be equal to 8. Now I've put that on a bracket there because you would normally, if we knew the numbers here, we would do 2 times the short run, the distance, you would do 2 times the length for the medium run, you would then add them together and get that value, and then you subtract. So that's why I'm including it there in a bracket. Just to show you then that whenever we then simplify this, well, if you've got 2y and you're taking away this, remember expanding the brackets, this is really minus 1 lot of that bracket. So we would have 2z take away, and then minus 1 times 2x would be minus 2x, and minus 1 times 2y would be minus 2y. So you can look at this in 2 different ways. You could look at it in terms of, I'm just going to get rid of that a minute and put a minus sign back in. You could say the total length of the 2 long runs, which is 2z either way. You could then take away the sum of the 2 shorter and 2 medium runs once you've added them together. Or another way you could work it out is say, well, work out the total length of the 2 long runs, which is this, and then take away the length of the 2 short runs and take away the length of the 2 medium runs. So that would be that. And that's what you get if you expand your brackets. So we've got the 2z minus 2x minus 2y would be equal to 8. And now we can just divide everything by 2, and if you divide everything by 2, we get that z minus x minus y is equal to 4, and that's what we're asked to show. And that's it. So just to show you that sometimes whenever you're making these equations, you have to kind of think through the information you've been given and work it out. Okay, so that's the second equation. Now let's have a look at the third equation. So we're then told in October, so we're jumping through a few months here, maybe her race is next year. We're told in October, Emily replaced the long runs with ultra runs, and each ultra run is 20% longer than a long run. And then we're told in October, she completes 14 short runs, 16 medium runs, and 10 ultra runs. And the total distance she ran during October was 350 kilometers. And part II, we've been asked to show that this information satisfies the equation 7x plus 8y plus 6z equals 175. Okay, so here we've got 14 short runs, so that would be 14x in terms of that distance, because it's 14 times the length of each one of those short runs. And the 16 medium runs, well, each medium run was y, so y kilometers, so that would be 16y. Now, we've finally been left with these ultra runs, and they're the things that are a little bit of a pain in this question, because if we think back in the question, we were told x, y, and z, and they were the short, the medium, and the long run. There was no mention of an ultra run, and also they're using z in the question, because if you look here, it says show the x, y, and z. So we need to get these ultra runs in terms of z. Now, if we think about it, we would normally do 10 times the length of the ultra run. But we know that the ultra run is 20% longer than the long run. So the long run is z. We know that. We know that the long run is z. And if you want to increase something by 20%, use a multiplier. Think back to percentages, multipliers, and there's a Corbettmaths video on multipliers. It's a fantastic video. Feel free to watch that. If you multiply something by 1.2, you increase it by 20%. So if we do 1.2 times z, 1.2z, that is 1.2 times z, which is increasing z by 20%. And remember, z was the length of a long run. So that means that each ultra run is 1.2z, because it's 1.2 times the length of those long runs. So it's 1.2 times z. So that means that it's going to be 10 times the length of each ultra run, which is 1.2z. So we're going to do 10 times 1.2z. And 10 times 1.2z would be 12z. So that means the total length of those 10 ultra runs would be 12z. Or another way you could have thought about it was that if it was 10 long runs, it'd be 10z. But that means that 10 ultra runs would be 20% longer, and if you increase 10z by 20%, that would be 12z. So that's another way to consider it. So that's fantastic. So we can now create an equation. We know that 14x plus 16y plus 12z is equal to 350. And then if we divide by 2, divide everything by 2, we get 7x plus 8y plus 6z is equal to 175. And that's it. That's what we're asked to show. So that's fantastic. And then finally, our last part will then be to solve these simultaneous equations. So we've been asked to solve them and to find the length of a short, a medium, and a long run. If it asks us for an ultra run, you would have to then find a long run and increase it by 20%. Okay, so let's have a look at these and see what we cancel out. Actually, I'm just going to call them equation 1, equation 2, and equation 3 to begin with. And I'm looking at equation 1 and equation 2. Because here we've got a z, and here we've got a z. And if we take z away from z, we get 0. So that means that if we take either equation 2 away from equation 1 or equation 1 away from equation 2, either way we're going to cancel out the z's, because here we've got a z and here we've got a z. So if we take the two equations away from each other, that z will cancel out. I'm thinking I'm going to do equation 1 subtract equation 2. So I'm going to do equation 1 subtract equation 2. So equation 1 is equal to, and by the way, with these three unknowns, you can do them in lots of different ways. Some people might actually think, well, let's leave the z's alone and let's cancel the x's or the y's, and that's totally fine as well. But I'm just going to cancel the z's here just because that's the approach that I would use. Okay, so equation 1, I'm going to write it out. 3x plus 2y plus z is equal to 40. And then here, we could rearrange the order if we wanted to. We could write it as minus x minus y plus z, because the z's positive, so you can put it there on the end, and then you've got your minus x minus y plus z, and that's equal to 40. So you could write that down beneath here, minus x minus y plus z is equal to 4. So just rearranging the order there, just so that it's lined up. That's probably what I would do if I was doing this question. I probably would just rearrange this one so that we have our x's, y's, and z's in the same order as the other two. So that's what I probably would do there. However, if you were to write down beneath z minus x minus y equals 4, you would just have to be careful that when you're taking away, you do the z take away the z, the 3x's take away the minus x, the 2y's take away the minus y. I think that's actually quite messy. I think more I think about it, I'm thinking that the approach I would use is actually to rearrange it just so that it matches up. It just looks better and feels more intuitive whenever I'm doing it. Okay, so we've just rearranged the order of equation 2. Now what we're going to do is we're going to subtract the equations because we've got a z and a z. 3x's take away minus x. I'm just going to write here for subtract, just that remember we're doing 3x subtract minus x. So we're doing 3x minus x. And that means we're going to add it on, so that'll be 4x's. Now we've got 2y's subtract minus y, so 2y's minus y, which would be 3y, so 3y's. And z take away z, which is equal to 0, so they cancel. And be careful with this bit, because some people think because we've been subtracting a negative, you've done 3x minus x, so you've added on. We've done 2y's minus y, so you've added on. We are still subtracting here, so 40 take away 4 is 36. Some students accidentally write here 44 because they're doing 40, and then they think they're minus and minus 4, but you're just subtracting 4, so it's going to be 36. Okay, so I'm now going to label this equation 4 because we've got an equation here without any x's in it. Okay, so that's fantastic. We've now got one equation where we've eliminated z. Now we need to get another one, and we've used equation 1 and equation 2, so we need to either use equation 1 and equation 3 or equation 2 and equation 3. Now here, obviously, people may have their own preferences. I'm going to probably choose the wrong one whenever I'm doing it, but it'll work out no matter which way you do it, as long as you're following the technique correctly and you're solving your simultaneous equations correctly. I'm going to times either equation 1 by 6 or equation 2 by 6. Because both ways that'll give us 6z, and we've got 6z here. I'm going to choose equation 1. I'm going to times equation 1 by 6. I'm going to use equation 3 and 6 times equation 1. So let's times equation 1 by 6 to begin with, okay? I'm probably choosing the messiest choice here, but let's see. So 6 times equation 1. So if we take equation 1 and we times it by 6, 6 times 3x is 18x. 6 times 2y is plus 12y, 6 times z is plus 6z, and 6 times 40 is 240. It's looking a bit messy here. So that is 6 times equation 1. And we've got equation 3. Let's write equation 3 beneath it. And we're going to do 6 times equation 1 subtract equation 3. And the reason why I'm subtracting them is whenever we write it beneath here, we can see we've got our 6z and our 6z. And whenever we subtract them, then they will cancel out. So let's subtract these equations and see what we get. 18x's take away 7x's, that's going to be 11x's. 12y take away 8y, that's equal to 4y, so plus 4y. And then we've got that's equal to 240 take away 175, that's equal to 65. So that's 65. Okay, now this is looking quite messy, and I'm thinking there's probably better options that I could have chosen, But let's just carry on and finish the question off. Okay, so we've called that equation 5. So we've now got equation 4 and equation 5. We've got 4x, 3y, we've got 11x and 4y. I'm thinking I'm going to times the top equation by 4 and the bottom equation by 3. And that'll give us 12y and 12y. We could times the top one by 11 and the bottom one by 4 and get 44x and 44x. That would be fine as well. But I'm going to do 4 times equation 4 to begin with, because then that will give us our 12y here. So timesing this equation by 4, 4 times 4x is 16x, plus 4 times 3y is 12y, and 4 times 36 is equal to 144. And now if we times equation 5 by 3, so 3 times equation 5, let's see what we get. So we're going to times this by 3, and we're going to get 33x plus 12y is equal to, and 65 times 3 is equal to 195. Okay, so we've got two equations with 12y in it. So now what we're going to do is we're going to take them away. So I'm going to call this equation 6 and equation 7 here, 6, 7. So we've got those two equations. Now we're going to take them away. And I'm going to do equation 7, take away equation 6, just so I get to say that in a different order. Rather than 6, 7, I can say 7, 6. So 7, take away 6. Okay, so equation 7 is 33x plus 12y equals 195. And equation 6 is 16x plus 12y is equal to 144. And when we take them away, we'll just have our x's. So 33 take away 16 is equal to 17x, and that's equal to, when we take these away, we get that's equal to 51. And if we divide both sides by 17, we get that x is equal to 3. So that's fantastic. Now got the x is equal to 3. So the length of a short run is 3 kilometers. That's great. Now let's have a look, and it's worked out quite nicely. Now it doesn't always have to work out nicely, but you know, you'll be able to check anyway and see if it's right anyway at the end whenever we substitute them all in. Okay, so we've got the x is equal to 3. Now let's find out what, if we go back up to one of these equations, 4 or 5, I'm going to go to equation 4, and I'm going to use the 4x plus 3y equals 36, and we'll work out what y is. So 4x plus 3y equals 36, and we're subbing x equals 3 into equation number 4. So if we substitute that in, for x is equal to 3, so 4 times 3 is 12, plus 3y is equal to 36. And then if we take 12 away from both sides, we get that 3y equals 24. And then if we divide by 3, we get that y equals 8. So the short run was 3 kilometers. The medium run is 8 kilometers. Now let's find the size of the long run. So let's go back up to the equations we were given in the question. I'm going to choose equation 1. So we've got that 3x plus 2y plus z equals 40. And we're sub x equals 3 and y equals 8 into equation 1. So if we substitute these in, 3x, well 3 times x is 9, plus 2 times 8 is 16, plus z is equal to 40. So we've now got the 9 plus 16 plus z equals 40. 9 plus 16 is 25, plus z equals 40. And then if we take away 25 from both sides, we'll find out what z is. So z will be equal to 15. So that's fantastic. We've found that a short run is 3 kilometers. A medium run is 8 kilometers. And a long run is 15 kilometers. And we found what x, y, and z are. If we wanted to work out what the ultra run is, we'd increase the 15 kilometers by 20%, and that would be equal to 18 kilometers, but we weren't asked to do that in this question, and that's it. And just to mention, if you substitute those into one of the other ones, you can check it. Let's just substitute them into this one here. So z minus x minus y equals 4. So 15 minus 3 minus 8, is it equal to 4? 15 minus 3 is equal to 12, minus 8 is equal to 4, so that works. So yes, we're correct. And that's it. And that's it. So in this video, we've looked at how to solve simultaneous equations with 3 unknowns in a context. You're quite often given in part 1, part 2, and part 3 parts to set up equations. There might be some equations that are quite straightforward, like this first example. There might be some that you need to think about. Just want to mention though that if, for instance, you were struggling with this third part here, you know, to work out the bit with the ultra run, and you think you've got it, but you're not quite sure, whenever you get to then the bit where you've got to solve them, focus on solving them anyway, the ones that you've been given, and try not to worry too much about that previous part, because it may just be worth a mark or two. But hopefully you'll be able to figure it all out anyway. And that's it. So I really, really hope you found this video useful. If you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.